Right. Assalamualaikum. Now this is the continuation, yeah, of chapter 5. Question 5 of tutorial 2. Right. Let's have a look at the information that we have, and we'll see whether we can um, solve the rest, yeah, if we understand, yeah, the concept behind question 5. Right. Let's have a look. Yeah. Now, the question says, calculate the wavelength in nanometer and the frequency of the fifth line in Balmer series. Yeah, the fifth line of Balmer series. Now, we have Balmer series. Yeah, so it is advisable that you sketch your energy level. Yeah, sketch your energy level just like before. So this is N1, N2, and 3 and 4 and 5, and we might need one more, I think, or two more. Yeah, and 6 and 7. And remember, the last one is infinity in bold. Yeah, bold. And here, make sure you label this as energy or energy level, yeah, for the y-axis. For the x-axis, it doesn't have any arrowhead, yeah, because it's the energy level. For Balmer series, we know that the electrons drop to n equals to 2. Therefore, in order to produce the first line, at least the electron must come from n3. Yeah, this is the process, the transition, but the product is what you see here, like the one I have here. Okay, maybe this is the first line, yeah, of Balmer series. Then, okay, we don't want the first line, but instead we want the fifth line. So the next one comes from 4 and drops to 2. For the third line, the transition must be from 5, which drops to 2. And the next one from 6 to 2. That will produce the fourth line. And the fifth line. Okay, we get the fifth line when the electron transits or drops from 7 to 2. Now, okay, knowing that, we can calculate the wavelength. There are two options. Yeah, we have, you can use the formula, the delta E formula, RH 1 over N1 squared minus 1 over N2 squared, together with, yeah, we know another one which has lambda in it, Hc over lambda, and we can equate them together. Or we can use the one which is automatically, which is readily combined for you. 1 over lambda equals to RH 1 over N1 squared minus 1 over N2 squared. Now, in this case, because lambda or wavelength is never negative, so we always take N1, which is the smaller value compared to N2. Now, let's substitute what we have. Before that, remember, this RH is different from this RH. The Rydberg constant for delta E is 2.18 times 10 to the power of negative 18 joule. But for this one here, it is already combined with Hc, and the Rydberg constant becomes 1.097 times 10 to the power of 7 per meter. Now, we have the n, the n values. So I think we can solve for lambda. 1.097 times 10 to the power of 7 per meter, 1 over 2 squared. Okay, this is what we get earlier, minus 1 over 7 squared. Okay, solve for this and take the reciprocal. That will give you the value of lambda in meter. But remember, the question wants it in nanometer. So what's the conversion factor? Remember, 1 meter is equivalent to 1 times 10 to the power of 9 nanometer. So whatever you get here, substitute and you can solve for the one in nanometer. Alright, that's all. I think you can solve the rest. Thank you.